Okay, we're going to talk about graphing and transformations on exponential functions for a bit. We started with our basic form y equals ab to the x. Remember, in this form, a is the y-intercept, and b is what we call the growth or decay factor. Oops, I need to write y-intercept there. Also known as the constant multiplier. This one showed up on the last test. This one is going to be, shows which one grows or decays faster. Okay, growth or decay factor. That's the other word we use for it. And remember, if we have other transformations, we want to start by taking it and graphing this form. So if I've got something like y equals -2 times 3 to the x minus 1 plus 4, we've got several things to take into account. So I'll graph that later, but we're going to start by graphing -2 times 3 to the x. On this one, my y-intercept here is -2. So -2, -4, -6, -8, -10 here. So when I graph this, I get a y-intercept of -2. If I want to plot the point 1, might be a useful point to have. I go 3 to the first is 3 times -2 is -6. My asymptote on this one is 0. So by graphing this, now I can just move my points. Oops, I should have done that in black. Let me do that in black so that it matches the color of the graph. The 2 and then 1, -6. Asymptote being 0. This is going to grow really quickly. 2 would be -12. I don't quite have that on my graph here. So now I'm going to graph my original, and I'm going to do that in red. So I've got this graph, and then this -1 in the exponent is a horizontal shift. I'm going to the right 1. And then this vertical shift is up 4. Remember that this is opposite the sign in the horizontal direction. It's the same for the vertical direction. So shifting up 4 means I'm going to shift my whole asymptote up 4. I'm going to indicate that with a dashed line. I don't need to shift asymptotes left, right, because they're lines. But each point needs to go to the right 1 and then up 4. So I'm going to take this y-intercept point, go to the right 1 and up 4. It's right now here. I'm going to take this point here at 1, -6, go to the right 1, that's 2. Up 4 is to -2. And my final graph is going to look like this. Okay. And the last thing we need to review is taking some data and using Desmos, and you will be allowed to use Desmos for the question like this on the test, and taking some data and putting it into Desmos and then generating a function. Okay, and so here we have Desmos, and I've already entered my data. Remember, to do that, I can go to the plus here in the corner and do table. Notice my data is x1, y1, and I can't see all of my data points. So I can use this little plus here to do zoom fit, or you can use the wrench and adjust it. Zoom fit seems to work pretty nicely. Now I've got all 5 data points, got a little bit extra. I could have used the wrench here and adjusted my X and gone, I need a little below 0. They did negative 0.5, a little above 1.5. They went a little bit, they went 2.25. And then I needed to go a little bit below 0 so I could see the axis. They went -9. I might have gone -5. Bigger than 18. They did 27. I might have done 25. Again, any of those though are fine as long as you can see them all. To generate my function, I need to do essentially y equals ab to the x, but I'm doing y1 to reference my point here. These y's. And I will do x1 to reference these x's. If I want it to calculate, I must do the tilde not equals. But I'm essentially just doing y equals ab to the x. Okay, make sure you know how to enter that. And it generates this function. We have a very good r squared, which means it fits very well. That's my correlation coefficient. Not exactly, but for our purposes, that's what it's going to be. My function, I then take my a and b. Remember to keep lots of decimal points on these, at least 3. And this is the exponential function I have generated. Again, 2.304 is the y-intercept. My growth factor is 3.935. Okay. Make sure you get all of this stuff in your notes, and you can use this to help you with the review sheet.